Hello everyone. So today in this presentation I'm going to explain you guys about what is this overfitting and underfitting in machine learning models. So let's get started with the video. So what is this overfitting and underfitting is what's the meaning of them? So the overfitting and underfittings are two common issues in machine learning that affects the performance of models. These problems arise when a model doesn't generalize well to unseen data, and they are typically associated with the model's complexity and its ability to capture patterns. So now coming to the topic of overfitting. So the overfitting occurs when a machine learning model learns not only the underlying patterns in the training data but also the noise and random fluctuations. As a result, the model performs well on the training data but fails to generalize to new, unseen data and leading to poor performance on the test set. Now, what are the symptoms of overfitting? So so the symptom says that high accuracy on training data but low accuracy on test or validations no data is a clear symptom of overfitting here. And if the model is too complex and has too many parameters relative to the amount of training data, it is a clear symptom of overfitting as well. And the model captures noise or outliers in the training data that leads to an overly specific model that cannot be generalized. So how can you identify the overfitting? So we can perform comparisons. Like if the model performs significantly better on the training data than on the validations or test data, it is a sign of overfitting. Learning curves. When the training error continues to decrease but the validation error starts to increase, it's an indication of overfitting. So, what are the strategies and preventions that we can use in overfittings? So, we can use cross validations, regularizations, pre-neoning, early stopping, simplifying the models, and increase data. So let's get through this all of these points. So in the cross validation, we use the techniques like k-fold cross validations to ensure the model generalizes well to different subsets of data. In regularizations, we apply techniques like L1 lasso or L2 ridge regularizations to penalize large model weights and reduce complexities. And in pre-running for decision trees, we cut back on the tree's depth to prevent it from growing too complex. With early stopping for neural networks, monitor performance on the validation set during training and stop when the performance starts to degrade. And with the simplifying the model by using the simple models with the with the fewer parameters, example linear regressions instead of polynomial regressions. With increased data, gather more training data to provide a better representation of the underlying distribution and reduce overfitting. Now coming to the underfitting. So what is it? So underfitting occurs when a machine learning model is too simple to capture the underlying patterns of the data. It fails to learn from the training data and exhibits poor performance both on the training and test dataset. And the symptoms of underfitting is when high bias in the models, meaning it makes strong assumptions about the data, The model is too simple to represent the complexity of the data that leads to the poor performance on the data training and set and the test data. The model cannot capture key patterns or relationships in the data. And now, how can we identify the underfitting here? So, by performing the comparisons. So, both training and test errors are high. That indicates the model is not capturing the relationship in the data. Learning curve says that if both training and validation errors remain high and do not decrease, the model is likely underfitting. So, what are the strategies to prevent and mitigate this underfitting things? So, we can use increase model complexities. Here, using more complex models or adding more features that may better capture the patterns in the data. For example, using polynomial features in regressions is a very good thing that we can use to prevent this underfitting. And the second point is about the remove strong assumptions. If using simple models like linear regressions, check if the assumptions are too restrictive and consider more flexible models. For example, decision trees, random forest. Third point says about the increase increase training time. Sorry. So if using iterative models like neural networks, it increases the number of epochs or iterations to allow the models to learn more from the data. Add more features here. So by adding more features, it includes more relevant features or try feature engineering to better represent the data. So what are the summary of overfitting and underfitting from where you can understand it very well and keep it in your mind that overfitting is this and underfitting is this. So here we go. So the model performance with the overfitting is high to train data, is high to training data, but low on test and validation data. And with the underfitting data, the model performance is high training errors, is with the high training errors and high test errors. So it's both side errors things with the underfitting, but it is at a higher scale when we are training the data with overfitting here, and of course on the test data and validations, it is low. So the biases with the overfitting is that it's low bias and very variance. It's high variance, where the underfitting is high bias and low variance. The symptoms of overfitting is that it is complex, that its complexity is too high, and it fits noise with it. And the symptoms for underfitting is model, it's too simple, and it fails to capture data patterns sometimes. So what's the solution for overfitting? So we can use regularizations, simple model or data or more data, and we can use cross validations to easily get the solutions for the overfitting. But with the case of underfitting, it's more complex models can be used to have to have a clear simple solutions, and we can use feature engineering, and we can remove the assumptions that are being forced to the underfitting things. Now the conclusion says that overfitting leads to overly complex models that doesn't generalize well, while underfitting occurs when the model is too simplistic to learn and data and data's underlying patterns. Identifying these issues requires careful monitoring of the model's performance on both training and validation test data. Mitigating overfitting involves using techniques such as regularizations, cross validations, and model simplifications, whereas preventing underlying underfitting involves using more complex models, adding more features, and adjusting the learning process. So yeah, that's it for the presentation here. My name is Rohan Lakhan. I hope you like this explanation, and if you like this video, give this video a hit like button. Do hit the like button